In exercise 806, we're still using the cosine rule. However, we're going to be finding an angle, and very conveniently on the reference sheet they actually give you a version where you can see that the subject is the angle, cos of the particular angle is equal to this calculation. So now definitely if the angle is the unknown, it's the thing that we're finding, the angle, then we must be given all three sides. We can't have anything here, and you can see they're all lowercase letters, so they're all sides. We can't have any of those as an unknown. These questions should be really obvious to spot, so there'll be numbers on all three sides of the triangle. It is really important that you realise the positions of each one of the sides, in that the angle that you're finding, its side length must sit in that position. So the angle that you're finding and the side length opposite it must sit there. It's the only thing that is subtracted, and you must make sure you get that in the right spot. There's one more step after that, and that is to actually find the angle, not just the cos of the angle, but the actual angle. And to find the angle, hopefully you remember, you would be taking the cos inverse of this calculation. Your a squared plus b squared minus c squared all over 2ab. Now we've done that sort of thing before. The calculator works really nicely with the fraction button in this situation, and just make sure you always close your bracket at the end. There's no complication with this one. If the angle in the triangle is obtuse, then the calculator knows and it will tell you the obtuse value straight up. So remember back with the sine rule, the calculator didn't tell you the value of the obtuse angle, and if you recognise that you have to give an angle bigger than 90 degrees, then you had to make the adjustment with the sine rule. That's not the case with the cosine rule. It's all very nice and straightforward. So we'll label the unknown angle C. We'll label the side opposite that angle that we're finding, lowercase c, and A and B on the other two. We'll write the rule in this format, or even this format if you like. We'll substitute into the equation, and we'll remember to use cos inverse to find the actual size of the angle. Let's have a look. So clearly here, so obvious, isn't it? Finding an angle, all three sides of numbers on them. Don't get that very often. It's not a right angle triangle. So what do we know? We're going to label that C, and this is C. So we write the cosine rule. So cos of C is a squared plus b squared minus 2ab. Sorry, do well to follow my own advice, which is to make sure I copy it down correctly, 2ab. So angle C is the cos inverse of this fraction, and making sure that it doesn't really matter about A and B, but making sure we've got C in the correct spot. The value of C is 9, which is subtracting 9 squared, and we've got the A and B is 20 and 16. So going to the calculator, you can see we've got cos inverse 20 squared 16 minus 9 over 2016. 2 times 2016, making sure we close that off, equals 26. Now these are degrees. We're working in degrees. 26.04. It didn't say, so let's just say 26 degrees to the nearest degree. So I've tried to choose some different types of examples to go through with you before you get started. So in this next example, obviously there's no diagram, there's very few words. It's not like it's a real problem style question. So how do we do these? Well, clearly we need to draw the triangle. It says in triangle GST. We get to choose where G, S and T go. So G, S and T. Where G to S is the same as S to T. So this side, G to S and S to T. Those two sides are equal and they're both 8.4. 8.4. G to T is 12.7. Calculate, so we've dealt with the information given. A says calculate angle GST. Start at G, go to S and continue on to T. Hopefully you can see that you trace out from G to S to T. We've traced out this angle. Now, if that's the angle we're finding, what we've previously said is we would like to call that C, and this side lowercase c, then the other two sides are going to be our A and our B. So let's go with that. So subbing into our formula, we've got, we're calling it angle C, is cos inverse. Our A and B were our 8.4. Subbing those in, 12.7. It's so important to get that 12.7 in the right spot in your fraction. Over 2 times A and B are the same. Now, we're going to calculate that, and you can see that's here. Cos inverse 8.4, etc. is 98. Sorry, we definitely don't need any square root there. We're finding the angle. I've gone back and named it angle GST, and that would be to the nearest degree. Well, we'll write it up as we should. 98.217, which is rounded to the nearest degree, which is 98 degrees. Then it says calculate the angle T to G to S. Now, we can save ourselves some time here if we understand the type of triangle that we've got. Because these two sides are equal, then we should know that this angle and this angle are also equal. They're the feature of an isosceles triangle. It would actually have been better if this question had C had come before B. If you recognise the triangle is isosceles with 2 equal sides, and there was the information that told us we had 2 equal sides, then the angles opposite them will be equal. So what we know is that they have split between them what's left out of 180 degrees. So angle TGS will be half, TGS, so this top one, will be half of what's left over out of 180 degrees when we take the 98 off. So take off the 98 for angle C there, and we get, which is 41. We've answered C, what type of triangle is GST? It's an isosceles, and find the angle GTS, it's this one down the bottom here, which we've already established is the same as TGS, so we can write the answer straight down. We don't need to do any calculating. I think I'll stop the video there because it's getting long enough, and I'll do the next 2 examples in the new video.